combination. So your task is to count the number of ways to construct sum n, okay, sum n by throwing dice one or more times. Each throw produces an outcome between 1 and 6. Okay, for example, if n is equal to 3, there are 4 ways. Okay, and we have stated this 4 ways, and modulo we have to answer with modulo. Okay, so it says, let's say we want to get some n, so we can only achieve when 1 has been, we got 1. If you want to achieve 2, then either we can get 1 plus 1 or directly 2. If you want to achieve 3, then 1 plus 1 plus 1, 1 plus 2, 2 plus 1, and 3. Since order is mattering here, right? Order matters. Yes, we can see here an example, right? For n equal to 3. So what I'm getting is, let's say if I want to achieve n, right? So how I can get n is if I received n minus 1 sum and I got 1 after that. If I received n minus 2 sum, then I got 2. If I received n minus 3 and I got 3. Received n minus 4, I got 4. Similarly, if I received n minus 5, I got 5 after that. I got n minus 6 earlier and then 6 I got. So our f of n, that is what we needed. That is f of n minus 1. Since we are adding 1, that is one way, plus f of n minus 2 plus 2 we are doing, right? So it's, since there's, once we got n minus 2, since we have already considered 1 plus 1 here, since from n minus 2 we would have added 1 and then we are adding 1, right? So from n minus 2 plus 2 we are only considering plus 2, not 1 plus 1 and 2 for 2, right? So each thing would be like ones till so on till f of n minus 6. So this would be where, right, if within f of x, okay, I'll remove some things so I to get clear understanding. Okay, I'll write it here. If f of x and x becomes less than equal to 0, because there is one way we can get 0 is we don't roll the dice and we got the answer 0. That could be one way, right? But anyway, our constraint is 1 to 10 to 6. So if x is less than 0, not equal, then our answer is 0. But if x is equal to 0, then our answer is 1. Why? Let you know. So since, let's say I want to receive 1, so what my f of 1 would be? F of 0 plus f of minus 1 plus f of minus 2 and so on. It's all negative, right? So this all will be 0. What would be 1? F of 0, right? So once you have received 0 means you don't need to throw dice. That is one way. Okay, now we will see the code, how we can make this thing work programmatically. So okay, I'll remove. Okay, so our code would be like since first we have to take n as input and our mod is what we see, that is 1 to 10 to the power 9 plus 7. This is how we represent it in C++. We are creating a dp of n plus 1 number, right? Because we have to preserve our last 6 digit, right? So one more optimization somebody would have created is he would just have created dp of 6, but each traversal he has to just make sure that his index is mod 6, right? So it starts from 0 1 2 3 4 5 again back to 0, so that he won't lose. Okay, maybe not 6, it's 7, because we have to keep last 6 and the current one, right? And if somebody is thinking to preserve current, then he can have it. So that is one more optimization somebody could have did it here. Just for easier explanation, I have taken it as n plus 1, since we consider dp of 0 as 1, that we have understood. And then just we are traversing from 1 to n, we are going from 1 to 6, right, that we discussed. And since negative we are already getting a 0, so we are trying to avoid it using I minus j should be greater than equal to 0. We are anyway skipping, we are not adding anything at that. And then finally our dp of n will preserve the answer, right? So dp of n is nothing but f of n. So your dp of I would be preserving your f of I, right? So answer would be f of n in that case. And the optimization that I was seeing to you is dp of, somebody make dp of 6, right, and a current element where he preserves. So he'll just add from dp of 0 to every number to dp of 6, right? Then let's say if n was equal to 7, right, at that moment, so he'll insert the number at this place 0 again, right? This would be 5 because we are considering it from 0. So he is inserting again at okay, so so inserting it again at 7, so 0, if, because then 0 would be of no use for us. Then if n equal to 8, then he would preserving it in this one, and his current would be like, once while he is inserting, he'll just remove this number from current minus dp of whatever index we are talking about. Okay, I'll write it again for better clarity. So cursor would be like cursor minus dp of idx, right, and whatever the previous cursor was, right? Or we can say cursor. Okay, so this is sum, sorry, this is, so sum would be sum minus this plus cursor. So cursor is something that person is going to get updated. Just for a better clarity, I've made cursor to sum because that's what we are trying to identify. So that is what this is. Now we'll execute this code. Okay, so for code execution, okay, we'll try with that things that we have already tried. So we have tried n equal to 3, right? So let's see what we get as output. We are expecting 4.